Hello everyone, it's Benny, and don't worry, you're not experiencing deja vu. I have moved the RPG series into its own video series. So this is actually a new video, even though I already had a video 7 before I removed the RPG series. So now that that's all cleared up, let's talk about the topic of this video, which is how do we make things in 3D using Opengl / Lightweight Java Game Library. And the answer, as it turns out, is a little bit strange, but we'll get into that once we actually get into it. The first thing we're going to need, of course, is just something that runs. So, let's do the typical Opengl setup. I'm going to create a init display method. It's going to be called public static void init display, and this is just the standard stuff you have to do to set up any Opengl project. But don't worry, this won't be special because we're going to do it in 3D. So set display mode, I'm going to create a new display mode. It'll be 800 by 600, and then below that I'll do display.create. And I'll just do Control-Shift-I. And for display mode, make sure you have the Lightweight Java Game Library's display mode. And then surround this block with a try-catch statement. And that will create a blank window for us. Now below this, I'll need the game loop. And notice, I'm not doing initialize GL this time. And there is a reason for that, but I'll explain that when we get into it. Because again, we have to get something that can at the very least run before we can start talking about how we're going to get this 3D displayed in the window. So here I'm going to create public static void game loop, and no, and here we'll just do while not display.isCloseRequested. We'll just do display.update, and I'll leave it like that for now. And below game loop, I'm just going to create one final cleanup method, and in here I'll just be public static void cleanup, and here we'll just do display.destroy. And now we have a very basic program that will display a blank window. And this is a standard setup you'll need to do for just about every Lightweight Java Game Library application. And now that we've done that, we can finally start displaying three-dimensional things in this window. So let's start talking about how we can make something show up in 3D. Opengl has a lot of methods that you can use, and if you use them in the right order, and you loop the right things, you can make something that shows up in 3D. And that's what most tutorials will show you how to do. The problem with that is, it's pretty complicated, it's not very flexible, and it's all hard to code, it's confusing, it's just a nightmare all around. So I'm going to be taking a more object-oriented approach to developing 3D, because just the traditional methods, they're not that useful. They don't teach you how to make something that can be expanded at all. It's just how to display something, and that's not what I want. So let's start thinking about what we need to make something that displays in 3D. If you start thinking of the Opengl window as not displaying just a complete black, but rather being a view into a completely empty world, then that's the first step into making something 3D. Because the first thing we need in 3D is if we're having this 3D world, we need to be able to look into it. We need a camera. We need something that is, okay, this is where our eye is. This is where we're seeing. And that's the very first thing I'm going to make. I'm going to make a camera. So I'm going to right-click on my package and create a new Java class called camera. Not cam ear, not, that'd be a very interesting way of creating 3D, but no, we're going to make a camera. I almost did it again. We're going to be making a camera. And Opengl, by default, does not have a camera, so we have to make our own. So what information does a camera have to have? Well, the first thing is, it needs a position in a 3D world. We need some location where our camera is. Makes sense. So, we're going to have a private float for our X position, private float for our Y position, and private float for our Z position. So we just have x, y, and z coordinates. That represents where our camera is. Nothing too mind-bending just yet. Next thing we need is we need rotation. And the reason for this is, if we just have a position, that's great, but we also want to be able to look around. We want to be able to look up. We want to be able to look down. We want to be able to rotate sideways if we really want to for some reason. So we're going to create rotation. So I'm going to create private float, rotation x, private float, rotation y, and private float, rotation z. And this will just represent what our rotation is. How much we're rotated in x, how much we're rotated in y, and how much we're rotated in z. And as far as positioning goes, that's all the information we really need. Everything else we're going to do in the camera class is going to deal with how making things look like. I'm sorry, I'm confusing myself now because I'm trying to go over too many things at once in my head. All the rest of the variables in our camera class are all going to deal with 3D specific information, like how much are we going to be able to see, how far are we going to be able to see, etc., etc. And the first of these variables is field of view. So what on earth is field of view? Field of view determines how much we're going to be able to see. And in essence, all it really is just an angle. And you might be wondering, well, how can an angle determine how much we're going to be able to see? And for that, I bring you to paint.net. Let's say that this dot right here is our camera. And let's say that this line just represents the direction that we're looking. And in reality, we're representing this line with these three variables, but just for purpose of demonstration, let's say this line just represents what direction we're looking in. So, field of view, like I said, is an angle. And what it will do is half the angle will be distributed this way, the other half will be distributed this way. And this angle right here, that is field of view. That angle between these two lines. And what this does is, if I have just a 3D scene that I'm drawing here, if I have a box here, let's say I have a couple of boxes, this is my 3D scene. Everything that is inside this cone that is created by field of view, all of that will be on my screen. Those will be things that I can see. If everything that's outside of this cone, those will all not be in my screen. So this is how it works. Everything in the cone is in the screen. And that's sort of how OpenGL emulates the perspective. It's not exactly how, but it's a close approximation of how. And that's how field of view determines how much we can see. If I wanted a wider angle, then as you can see, I have more of the 3D scene in my view. If I have a smaller angle, then as you can see, I have less of the 3D scene in my view that I can see. And that's all field of view is. So that's field of view. So I'm going to create a private float field of view. Okay, that's the first. We need 3 more. The next thing we're going to keep track of is the aspect ratio of our display. Now it might seem like, that's weird, why would we need to know about that? Well, if I go back to paint.net just really quickly, you see we have this image captured by field of view. But it's all in this sort of cone format. How do we sort of transpose that into our screen, which isn't a cone, it's pretty much a rectangle? That's what the aspect ratio determines. It determines how OpenGL, well, it determines a shape that OpenGL is going to transpose that cone into. What shape of rectangle? Because if you if you know the definition of an aspect ratio, it's just the ratio of the length of a rectangle to the width of the rectangle. So that, in essence, is all the aspect ratio is going to do. OpenGL is going to take the aspect ratio and use that combined with the cone it generated from field of view, and it's going to transpose a rectangle from that. And that's what will ultimately end up being our view. So I'm going to create a private float. I'm just going to call it aspect. That'll be our aspect ratio. And now we only need two more things to generate a 3D view. And the first of these is probably the most confusing. It's called the near clipping plane. And I actually can demonstrate this. So this is our point in our 3D space, and what the near clipping plane is just a literal plane. It's a line that goes right here. And if something is in my field of view, but is behind this line, then OpenGL clips it. It doesn't draw it. And that might seem really, really weird at first. It might seem like, okay, why on earth would I not want to display something that's right in front of my face? And there's a technical reason for that, and for brain-hungry people, I'm going to just quickly explain that to you. The reason the near clipping plane exists goes back to the clipping algorithm, hence the term near clipping plane. What clipping does is when OpenGL draws a 3D shape, it doesn't literally fill in the shape. What I mean by that is, if I draw a square, let's say this is a 3D square in OpenGL, OpenGL doesn't take the time to go pixel by pixel and fill the entire square with red or green or whatever color the square is. It will use matrices to approximate it, and it'll end up being sort of this splurge, and you'll get some glitchy effects like this line that goes down. It's where textures just sort of bleed out because of this matrix approximation. It makes it work a lot faster, and we wouldn't be able to draw things if it didn't do this matrix approximation, but we get these splurges and these bleeding effects. And what clipping does is it goes in behind it, and anything that's not inside the shape that you're telling OpenGL to draw, it will clip it. So this line will essentially be erased. Well, it won't be erased, it just won't be drawn. And this clipping algorithm depends on the near clipping plane. And if I set this to 0, then it won't have any point of reference to clip from. It will just leave all these splurges in. So if you want to have all the splurges in, just set your near clip value to 0, and you'll see all the glory and glitchiness of this matrix approximation. But we still need to have that near clipping plane, or else we can't actually do that clipping algorithm. So I'm just going to call this variable near. And the final variable that we need is the far clipping plane. And this one isn't as tightly related to clipping, but what the far clipping plane will do is it will have this line right here. Anything that's past this line, so like in this square right here, for example, everything behind that line will not be drawn. And the reason is, if we didn't have this, we'd just be seeing off into infinity. And there's nothing inherently wrong with that, but it looks really glitchy and it ends up looking really bad. And also, it takes a lot of processing, so it saves processing and it makes it look better, generally speaking. And that's why we have the far clipping plane. So, I'll just create private float far. And those are the 4 variables that we need in order to draw a 3D shape. Or, not draw a 3D shape, I should say, but rather just to create a camera. So, now that we have all this information, we need to start using it, because it's not doing much good just sitting as a variable. So, let's start adding the functionality of the camera that makes it actually work. So I'm going to create a constructor, so public camera, and in my constructor I'm going to take in a couple of parameters. I'm going to take in an X position, a Y position. Actually, I'm not going to take that in. I'm just going to take in the field of view, aspect, the near plane, and the far plane. That's all I'm going to take in. I'm going to initialize all these values to 0. So I'm going to set x equal to 0, y equal to 0, z equal to 0, rotation x to 0, rotation y to 0, and you guessed it, rotation z to 0. So I'm going to initialize all those to 0, and this .fov, I'm going to set FOV, aspect, aspect this dot near equal to near, and this dot far equal to far. And now that we've done all that, we're going to create what I guess you could call the substitute for the initialized GL method that we have in 2D. And I'm just going to call this method, it's going to be a private method, it's going to be void, I'm going to call it init projection. And this will do a lot of what the initGL method does in 2D, but this one's just focused on initializing the projection matrix. And in 3D, that's really all we need to set up to draw something. So that's why I'm excluding the initGL method, because we don't have anything other than the projection matrix set up. So first, we need to import the OpenGL methods. So import static org.lwjgl.opengl.gl11.star. And now, all we need to do is not that. We need to first switch into the projection matrix. So I'm going to do GL matrix mode, and I want the projection matrix. So GL projection. And now that we're in the projection matrix, we want to clear out anything that's there. So GL load identity. And now we need to set up perspective. You could do an orthographic 3D view, and if you did, you wouldn't need these variables. But I want perspective. I want it to look like our eye sees it. So I'm going to create perspectives. This is GLU, the perspective, and this takes in field of view, aspect, near clipping plane, and far plane. So just those 4 variables. Method cannot find symbol GLU perspective. Okay, that's interesting. Did I, oh, I forgot to import it, of course. Okay, so what we have to do is we have to import static org.lwjgl.util.glu.star. So, it's a little bit more, but it gives us access to GLU perspective, which will set up a perspective projection using the 4 variables that we're keeping track of. So, now that we've done all that, all we have to do is we have to switch back to the switch back to the model view matrix. So GL_GL model view, and that should be everything for the projection. Now all we have to do is we have to call the method, and that will set up a 3D projection, but it won't really mean very much just yet. And what we have to do to make this all actually mean something is we have to do just one final thing with the camera. And that is, we have to be able to set it so that we're viewing from the camera. We have to be able to set it up so we're looking through the camera, because it doesn't make sense to have a camera if we can't look through it. So I'm just going to create a public method called setView. And what this method is going to, in theory, do is it's going to set up our view, whatever our screen is displaying, so that we're viewing from wherever this camera is. And that's where all these variables come to play. So, first off, what we're going to do is we're going to have to shift over to the position. So I'm going to do GL. Actually, we want to do the rotation first. So we're going to want to GL rotate F, free F. I thought it was rotate F. Method cannot be, oh, I didn't put parameters in, no wonder. I'm sorry, I'm tired, it's getting late. So GL rotate F, we're going to want to rotate by rotation X, and we're going to select the X-axis, and we don't want to apply that rotation to any other axis, so I'm just put 0. Then I want to GL rotate F, I want to rotate the rotation Y, I'm not going to apply this to the X-axis, I'm going to apply it to the Y-axis, and not the Z-axis. And lastly, I'm going to want to rotate for the Z-axis. Don't want to apply that rotation to the X or Y-axis, but I do want to apply it to the Z-axis. And now we should be oriented correctly. Now all we have to do is move the camera to the correct position. And I'm going to do this with GL Translate. And all I have to do here, for the time being, translate. I'm forgetting to put in the parameters. That's why I'm getting the error. I'm tired. We're going to do GL Translate for our X, Y, and Z position. And this won't be entirely correct, but I'll sort of explain that when we get into using this. So, for now, that will be good enough. So now we have all that set up, I'll just do it in the game loop method. Since this is temporary, cleanness isn't exactly the most important thing in the world. I'm going to create... Oh, I almost forgot. I need getters and setters for all these things. So I'm just going to create getters and setters. So public void, public float get X, public float get Y, public float get Z, public void set X, public void set Y, public void set Z. And I also need for rotation X and Y, so I'm just going to copy these and change it so that it's RX, RY, and RZ. And in getX, I'm just going to return X. In getY, I'm going to return Y. GetZ, I'm going to return Z. SetX, .x equals X, whatever. Then pass in X. So I'm going to take in a variable called X. Set Y, this dot Y is equal to Y. I need to take in a Y, so I'm going to take in float Y. Yeah, this is pretty much the one disadvantage to doing things like this. But on the plus side, this will make things a lot easier down the road. So float Z, this dot Z is equal to Z. And get RX and RY and stuff. I'm just going to copy and paste this. So, just copy and paste, change it to get RX, so RX, RY, RZ, set RX, set rotation Y, and set rotation Z. And instead, I'm just going to change everywhere where it says X and Y or Z, I'm just going to put an R in front of it. And that should be our getters and setters for everything we need now. Now if I go back to... yeah, here. What's this? Oh, that's from another project. I can close out of that. So in here, I'm going to go back to my game loop. I'm going to create a camera. So I'm going to create a camera, cam. It's going to be a new camera. And now we just need to pass some parameters. So field of view. What should be a good field of view? As it turns out, there's not really a good way to approximate the field of view of the human eye, but a pretty close approximation is 70. It's not perfect, but it's a pretty good approximation of the field of view of our human eye. Aspect ratio, that will be dependent on what our display is set to, so I'll do display.getWidth over display.getHeight. And you should notice this is the formula for calculating an aspect ratio. The problem is we have to cast both of these to floats. And that's very important, or your aspect ratio will be wrong. So, and now for near plane, generally 0.3f is a good near clip plane. You do not want to set it to 0 because of all the glitches we talked about earlier, but 0.3 is generally good. And for far clip, 1000 is generally a good far clipping plane. And that has set up a camera. So, now in our actual game loop, what we want to do is we want to every frame, first off, we're going to do standard frame stuff. We want to do GL clear. We want to clear the color buffer, so GL color buffer bit. And we also want to go back to the GL just load identity. That will reset our model view matrix. And here we have to import, so import org.lwjgl.opengl.gl11.star. It has to be import static. And there, now we have those two methods. And the last thing we want to do is we just want to do cam.setView. There. Actually, I'm going to change this name to useView so it doesn't get confused with the setter. And so I'm just going to change this to cam.useView. So now we're going to be looking through this camera that we set up. And that's good. That's what we want. So if I run this really quick, you'll see that we still have absolutely nothingness. But at least now we have a special kind of nothingness. This nothingness is actually, it's like us looking into a blank space rather than just displaying complete blackness. So we can't see the result yet, but it's a start. So all we really need to do now is we need to actually draw something that we should be able to see in 3 dimensions. So down here, I want to draw something. So I'll just do GL begin, GL quads, and not sure why let's do that there. There, GL begin, GL quads, and behind there I'll do GL end. And again, the parentheses are not parentheses. The braces are not necessary. I just put them there because I think it makes it look better. And to start off with, I'm just going to draw a square, like we've drawn many times before. So GL vertex, 2F, except this time I'm going to do 3-dimensional vertices. So I'm going to start at position 0, 0, 0. And then I'm going to draw to position 0, 1, 0. Then I'll do GL vertex 3F. I'll do 1, 1, 0, and GL vertex 3F 0, 1, 0, 0. And this should draw a plane directly in front of our camera. So first off, I'm going to actually put this in its own matrix. So GL push matrix, and again, put in parentheses, and GL pop matrix. This way we'll still have the our standard this way we won't affect anything we do in here will not affect the translation or rotation of anything outside of here. So, first thing I want to do in here is I want to set GL color 3F. I want to give it an orange color, so I'm going to do 1.0F, 0.5F, and 0F. And that sets us an orange color. That way we're just drawing an orange square. And final thing I'm going to do is I'm going to do GL translate F. I'm going to move back 10 on z-axis. And now if I run, I should get an orange square. And you're like, okay, that's pointless. It's exactly like every other square we've ever drawn ever. And yeah, that's true. But now it's 3-dimensional. And just to prove this, I'm going to create an int x, just temporarily. I'm going to set it equal to 0. And every time we update, I'm going to add a very small amount to x. And I'm going to add that x value to our translation for z. And cancelled. Why? Oh, I forgot a parenthesis, or forgot a semicolon. So now, this should be moving very slowly towards us, perhaps a little bit too slowly. So I'm going to increase the rate of this a little bit. Still a little bit too slowly. Is this even working? Hang on, this might not be working for some reason. Println x. Oh, wait a second. I'm putting this below display.update. And when display.update's called, yeah. So, now, it's still not working. And, oh, I declared x as an integer. I'm going to make it a float. Sorry for... I really should not be recording this at 5 minutes. Woo. Okay, that's a little bit too fast. But, oh, nope. Didn't mean to do that, but it should still work. So, you'll see, we actually have some 3D action. We actually have some 3D going on. It's moving towards the camera. That's still a little bit fast. So I'm going to slow it down even more so you can see it. So as you can see, we actually have a 3D effect of the square going to the camera now. It's definitely not perfect, but, you know, we get some 3D effect. And to demonstrate it a little bit more, I'm also going to do GL rotate, and I'm going to change, still do X. I'm still going to have the X variable, but I'm not going to use it for the same thing. I'm going to increase X by 1 every frame. I'm just going to rotate it by X on the X-axis. Why not? So, yeah, now it should be rotating in 3 dimensions. As you can see, it is. And that's still a little bit fast, so I'm going to change it to 0.1f. But yeah, you can see we have a 3D effect going on now. And I can make it rotate on more than one axis at once. Now it's affecting X and Y rotation. And we get sort of the 3D rotating on both axis effect. So, there you go. You get to see at least some very basic 3D going on. But let's not stop there. First off, I'm going to take out the rotation temporarily, just so we see a flat square. Actually, no, I can leave the rotation in. Why not? But I'm going to make this into a cube. So, we've drawn a square using the standard square methods. The standard way of drawing a square that we used every other time we've drawn a square. And this is just going to be the front face. Now, all we have to do is we have to do this 6 times with every combination of the axis. So in this case, we're doing X and Y. Now I'm going to do Y and Z. So here I'm just going to create this. And I'm still have unfortunately not memorized which axis belongs to which. So we're going to have to sort of just figure it out as we go along. So I'm going to do the exact same thing I did there, except this time on the Y and Z axis. And this, I'm not quite sure which face this set is. I'm going to disable animated rotation, just rotate by a hard 22 degrees. Okay, I think this is the left face. But in any case, we have another face. And now we just need 4 more. Jeez, I really am tired. We just need 4 more to finish our square. So I'm just going to guess that this is the right face, even though it's probably not, so I'm going to delete that. So we've done X and Y, we've done Y and Z, we can do X and Z, so there. And that will draw another face. So we've drawn half of a cube. I actually think that's the bottom face, so bottom face. So we're going to draw another face this time. We've done X, Y, Y, Z, E, and X, Z. We have not, however, done Z, Y. So I'm going to do Z, Y, which would be starting here. It just goes 1, 1, 1, 1. I believe that I'm pretty sure it's drawing from X to Z. Is it? Let's just see what happens. If we get some really weird shape, then we know we did it wrong. And we obviously did do it wrong because it's not showing anything new. Okay. Oh, I just realized what I did wrong. I screwed this up. I'm very sorry, everyone. But we have to do this again. I apologize. Remind me never to record videos when I'm tired again. So, the reason is because instead of going from 1 to 0, we need to range from -1 to 1. And we could do it if we don't do it like this, but it's just, yeah, it's not as easy. So, I'm going to start doing the exact same thing, except this time using -1 to 1 values instead of what we did before. So, yeah, hopefully you see that I'm just doing the exact same thing, except instead of using 0 and 1, I'm using -1 and 1. So, yep, next time I'm going to memorize what shape I'm going to draw before I try drawing it. And now we have the exact same thing, but you notice it's drawing so that it has room for the rest of the faces now. That's good. So now, front face, and we're going to have another face, which is going to be the exact same thing, except negative in Z. So, and I believe this will be the back face. I cannot hit shift, apparently. So that should be the back face, I believe. Yes. Okay, so now we're slowly but surely producing a cube. And there. So now we need the next one. So we've done both combinations of x to y. Now we're going to do the exact same thing that we were talking about. Instead of going x to y this time, we're going to just go... I'm going to start everything at -1. Oh, whoops. I'm just going to start everything at -1 temporarily. But yeah, instead of starting from going from x to y, we're going to draw from y to z. It's going to start at -1, 1, then -1, comma 1, and then 1, comma 1, and then finally 1, comma -1. And that should add another face to the cube. Yes, it adds... Which face is that? I can't tell. Oh, it's rotating weird. I believe that's the bottom. I believe it's the bottom face. So I'm just going to put, whoops, bottom, and here I'm going to do the exact same thing, except the axis we had all negatives. I'm going to make all positives now. And oh yeah, that was definitely the bottom face. And now we have most of a cube. In fact, we can't even see the two faces we're missing, but we are missing two faces, so we're going to go ahead and draw those. So, one of these is the left face, one of these is the right face. I have no idea which one's which, but we'll figure that out when we do something wrong, I guess. But it doesn't really matter, the labeling, but I'm doing it anyways, so yeah. So I'm just going to start everything at -1 again. And now we've done x to y and y to z. Now we need something that goes from x to z. It's going to start -1, 1, then 1, comma, -1, then 1, comma, 1, and then -1, 1. And our y-axis this time is the one that's constant. And this, I believe, should be the right face. And same thing, except we're going to make the y all ones this time. And now, even though it looks exactly the same, we've drawn a complete cube. So there, that's our basic intro to 3D. And yeah, I hope you enjoyed, I hope you learned something. Thank you.